We're looking at problem number 8 on the review for Performance 8, and it asks us to state the mean value theorem. You're not going to be asked to do this verbatim, but you need to know it in order to answer the following questions. So it goes like this. If a function f is continuous, meaning no discontinuities, on an interval, and if f is differentiable, meaning you can take the derivative everywhere, on the same interval, but it doesn't have to include the endpoints, then we know there is x equals c, where c is between the two endpoints of the interval, such that the derivative at c is equal to the average rate of change on the interval. Okay. So with that in mind, let's talk about why we need these two conditions. First, suppose that our A is right here and our B is right here. And let's violate the first condition. Let's make it not continuous. Notice that I could make these my endpoints, which means this is my average rate of change. But because it's not continuous, I could do something like this. Slope is 0 everywhere, and then slope is 0 again. So notice that it never achieves that average rate of change. So this right here is not necessarily equal to this at some point. Likewise, suppose this is our A and our B again, and this time we're going to violate condition number 2. This was number 1. On number 2, let's suppose this is our endpoint and this is our other endpoint. And so in this case, our average rate of change, this part, is going to be 0. Now if it had to be smooth, I would get this curve that would turn and we would have a maximum point where the slope would be 0. However, we're violating the condition of differentiability right there where we have the cusp, and so you can see that on this curve the slope is never 0.